to CreationWatch. So there's a few creationists that I don't mind interacting with or engaging with their content.
To creationresearch.net.
Not too many, because most of them are pretty toxic. Today's creationist is not too bad though. I haven't heard too many toxic things. There's definitely misinformation coming from them, but I don't want to say that they are necessarily a toxic influence. So we are going to explore. This is a clip of actually a interview that this person did on Standing for Truth's channel. It's SFT for anybody who's familiar with the community there. But yeah, Standing for Truth does young Earth creationism, and they have young Earth creationists apologists on, and sometimes they have young Earth creationist scientists on. Today's conversation is going to be about one of these scientists. And I don't doubt their credentials. And like I said, they seem like a fairly nice, decent person. But yeah, they're a young Earth creationist. And they make some arguments that I find dubious. I do plan on engaging with this person directly sometime in the future. So keep your eyes out for that too. I've been corresponding with them tentatively for a little bit now, so hopefully we'll get something set up so we can actually talk. Anyway, CreationWatch. So this was a kind of a spin-off of CONSERVAPEDIA. Once I started kind of burning out those articles, wanted to expand and dip our toes into some other creationist organizations. I don't mean to call CryptoCorner CONSERVAPEDIA a creationist organization. It's more of a creationist brainchild. But we're going to look at some of these different apologists on this show, as well as looking into CONSERVAPEDIA moving forward. And we're calling it CreationWatch. And please enjoy our look at an interview with Indiana Joe. Indiana Joe Hubbard is British. I like his aesthetic. I like the hat and the vest and the whip, and also, they talk about the same kind of stuff that I'm interested in, animals. So let's see. Let me know if the audio is okay on this. We're gonna see. They're talking about venoms, which, as you all know, I love venom. So we will see what they get right, what they get wrong. How that all pans out. So let me see here. All right, yeah. Let me know if the audio is good, okay?
Programs which I've done before, One Deadly Bite and The Poison in Me. Both of them were created out of a question that had been asked several times, but both of them were created for USA television, both to be about 20 minutes long, with David Reeves and co. So I've kind of mashed them together with a whole load of other things that we're going to sort of bring together. It should make sense as we work through. But remember, as we're working through, we need to make sure that we actually have Christ's mind in us. So let's dive into the first topic, One Deadly Bite. There's a snake. Now, I love snakes. I worked as a zookeeper, by the way, for 6 years when I was earning my first degree in geology and natural sciences. It wasn't the most cheapest thing on earth, so I had to sort of work alongside it. I worked as a zookeeper and sort of rose through the ranks, as it were, and ended up getting more and more responsibilities and taking on more and more care. And one of the biggest things that I loved was looking after the reptiles, looking after the snakes and the lizards.
So this is really cool. I was excited and surprised to learn this about Joe, and if I do talk to him, we're probably going to engage about that topic a bit, because I love herpetology too. We've had a few different herps. My son has a bearded dragon that sometimes comes down and hangs out with me. We've had my wife is a frogophile. She has her fire-bellied toads with their little twinkling waterfalls and stuff. So Yeah, absolutely love herpetology. We have had snakes in the past. I don't have any snakes now. I don't plan on getting any snakes. I like my bugs. I like taking care of my bugs. So probably won't happen. We may get another tortoise, like I said. But yeah, I love reptile husbandry as well. I'm super jealous that you got to work at the zoo. I wish that there had been a zoo close by here so I could have went and worked there while I was going to school. Would have been amazing. Yeah.
You'll find that they feature quite a bit as we go forward. But we're talking tonight about snakes in particular, but venom in general. Oh, by the way, we need to make sure we lay down some definitions, and we'll get a more technical definition as we go. But what's the difference between venom and poison? Venom is injected and is bad. Poison is ingested and is bad. So the old anecdote is that if it bites you and you die, it's venomous. If you eat it and you die, it's poisonous, right? But we'll come on to that a little bit as we go.
Well, okay, so venom and poison. So venom is a kind of poison. Poison can be anything that negatively impacts your health when it enters your body. So venom is a poison. Venom poisons your system. So it's better to think of it as venom as a subset of poison, like nested within poisons is venom. Not necessarily a separate thing, but venom's a very specific type of poison that is generally injected via fangs or barbs, but it can be used as a defense or as a predatory method. That's what I don't get about why he says it's bad. Venom and poison are bad. Who are they bad for? They're not. The venom's not bad for the snake. The venom's good for the snake. It needs its venom to defend itself, to subdue its prey. Spiders too. They need their venom. Venom's good for them. Venom's good for the platypus who, has its venomous spur to kick people who try to molest it, or kick predators that try to eat it. So it's good for the platypus to have its venom. So I don't know. This good and bad idea is very, what do you say, anthropocentric, very human-centered. For us, for a human, venoms are bad because we don't need venom, and venom is bad for us. But not bad in general.
Here's one of our snakes that I got to look after. This is a corn snake native to North America. Here's another beautiful little garter snake. Absolutely gorgeous, stunning colors. I think they're absolutely fabulous.
I think this garter snake's beautiful too. Love that green.
Although it does always amuse me that in the UK, where we really don't have to worry about snakes, we've only got 3 species. One of them is extremely rare, and only one of them is venomous, right? And it's not even that bad, a venom bite, right? People in the UK are terrified of snakes. You go to Australia, where you really do have a lot of reason to be scared of snakes, and most Australians don't bat an eyelid when you put up pictures of snakes. So hopefully we don't have anybody with a fear of snakes here tonight as we sort of move on forward. Here am I looking quite a lot younger, to be honest with you, working with another one of our snakes. You got to design enclosures. This is a big Burmese python.
This is really cool. This is something I enjoy doing too, is building enclosures. So I think that me and Joe should get along just fine if we hang out. We obviously have different worldviews as far as evolution and all that, but we have similar interests. But yeah, I love building enclosures for snakes and spiders and creatures of all sizes and shapes.
Then you've got to have a reasonable amount of knowledge about these animals if you're going to look after them and design enclosures around them, and actually make sure that they're fit and healthy and active. It was great to get up close and personal to these beasts, because understanding how the animals work really does help you with the fossils, with the dead ones. So I had a great time working.
Well, so helps you with the fossils. Does that include the fossil snakes with legs, with hind legs, with forelegs? So the convergence with the Veronid evolutionary lineage, does it include all of that?
Well, with these creatures, and here's one of your North American garter snakes. can you see he's sticking his tongue out at you? Now, he's not being rude, because most of you probably know that he is smelling the air. Or smelling the air is the layman's term for it. We'll come on to it in more detail in a minute. But you probably also know that snakes have a forked tongue. Now, I wonder how many of you know why a snake has a forked tongue. Now, I asked this question every single day, twice a day at snake encounter as we were taking snakes out and showing them to the members of the public. I only ever got the correct answer once in 6 years of presenting, right? Most people just simply don't think about it. And I like to remind people.
Well, I think he breaks this down later on here, but it's forked because it's directional, and they have two slots on the roof of their mouth that they stick those forks in. So they stick that out, and the snake's moving along, and it tells it whether to go, whether it needs to go left, right, or stay its course to follow the trail it's on. So they stick their tongue out, and it goes back in and pokes into two pockets right on the roof of its mouth where it brushes against the Jacobson organ. We're going to talk about that, the verminonasal organ, because you know what? It's not exclusive to snakes, and we have vestiges of those on our own heads.
Two things. Number one, if you don't ask the right questions, you won't get the right answers. That's vitally important in this topic and this whole sort of, topic, creation, evolution, Noah's flood versus millions of years, all of that. It's vitally important in general. But also, if you really do believe that God created the heavens and the earth as he said that he did, then everything will have a purpose. Everything will have a reason for being the way that it is, even if it is a mutation. Even if it is a problem, you will be able to trace it back almost to the original source or the original design.
This is the same stuff that we had last week with the guys saying trace it back to the original design. So snakes are allied with varanid lizards, monitor lizards, Komodo dragons. You can tell they have the forked tongue too. So they split off from the rest of the Lepidosaurus together and then diverged afterwards. Whether the snakes evolved for an aquatic lifestyle or a subterranean lifestyle has been hotly debated, but we can generally agree that they have split off from varanids. So you could draw a circle around snakes and varanids together and draw some correlations too, and say, hey, are these the same kind? Because they have these features that are the same. But and then of course we get into the legged snakes, and then you have the modern constrictor snakes with the claws on their lower, I guess it'd be their pelvic region, even though snakes don't really have a pelvis, but claws on the side of pythons that are vestigial. All right.
Why do snakes have a forked tongue? Well, we'll get onto that in a moment. Let's have a look at what they actually use this for. There's your simplified diagram. You see he's sticking his tongue out, he's got a forked tongue there, and he waves it around. Now, when we say he smells with his tongue, what we're really talking about is, well, he actually smells using the same thing we use to smell with, which is our brain. Right? When we smell, the odor particles go up your nostrils to the back of your nostrils to olfactory cells, which then take the information about the odors into your brain, and your brain interprets it, right? What does the snake do? The snake sticks his tongue out, waves it around, catches those odor particles on the brain, brings his tongue back in to his mouth, and sticks his tongue straight up into his brain, into this little part of the brain down the bottom you can see there, called the Jacobson's organ. And he literally wipes those odor particles off onto his brain, into this special little part of the brain, into the Jacobson's organ.
I just want to reiterate here that that humans, developing humans anyway, do have a vestigial Jacobson's organ called the verminonasal organ, and it's reduced, and it doesn't have much function, but it is there.
So he's not just sending information, he's actually putting direct from the source straight into the information processing part of his brain. Okay, why is this important? Well, what it means is that snakes do have a spectacular sense of smell. They actually build up a 3D picture of smells in their surroundings. They can smell up to a month-old smells. Right? In other words, if a rat had or a mouse had walked across my desk here a month,
this is definitely true. They can smell very, very old trackways and trailways. That's what most of the time when you see a snake out slithering around, it's following some sort of path or some sort of scent trail that you can't even see. Humans like to think that the way that we view the world is the proper and correct way. There are ways of sensing and understanding your surroundings that we will never get to experience, and this is one of those. Also, within snakes, there's the infrared or the heat sensing that we can see in like pit vipers. That we will never get to experience that. Most snakes have some degree of heat sensory along their snout there, but yeah, snakes have a great sense of smell.
ago some of those odor particles were left, then a snake would be able to pick them up. Now that's astonishing. That's way beyond our sense of smell, way beyond even animals that we usually associate with having a good sense of smell, like a dog, right? Way beyond that.
So the dog's sense of smell is a bit different. They are good at smelling things from really far away and tracking down those scents. It's because the way that the canines evolved to hunt, they would run down their prey, run it down, and it would eventually collapse, exhausted, and then they would. I mean, you can see that today with wolves as well. That the way that they tackle their prey. Yeah, sometimes they can catch it when it starts to tire out and slow down. Sometimes though it gets away and keeps running and running until it collapses. But the wolves need to be able to find it because the wolves don't generally try to keep up with it and catch it. They're trying to run it down. They're trying to give it no rest. It cannot stop. It cannot rest. It has to keep going because the wolves are on its track. So the wolves are good at smelling something far away. They are good at tracking trails too. Not as good as a snake, but the snake's prime benefit is that it can smell really old trails. It can pick up on the pathway of a rodent from months ago and follow that trail all the way back to its burrow and, find its babies, find it, and eat it. So yeah, this is kind of a different reason for the advanced sense of smell in these two clades.
And they actually build up a 3D visual picture of smells using their sensory systems. Fork tongue, one fork is for one side of the brain, the other fork is for the other side of the brain. It's to help in building up that 3D picture. Fascinating.
Yeah, it's smelling in stereo, basically, so that they know which direction to go.
Fascinating stuff, amazing stuff, brilliantly designed stuff. Of course, we then need to move on to the eating side of things because they will use their sense of smell in order to find food. Now, this is Whisper. Whisper's the snake, by the way, not the rat. We didn't name our rats before we fed them to the snakes, even though you have to have a little bit of a dark sense of humor to be a zookeeper most of the time. But you
have to have a dark sense of humor to be a bug keeper too, because I raise these roaches. I really have stopped feeding my dubia to my spiders. I've been feeding them just the red runners. The red runners look like a traditional pest roach, so I get a lot less attached to them. Whereas the dubia roaches, they look like the giant hissers or like a even similar to the domino roaches. So yeah, they're a little bit cuter, and it's I can't. I have, and I probably will in the future, fed them to the spiders, but it's much easier to to feed them the fast ones. And the mantises prefer the fast ones because they like something that's visually stimulating, and dubia tend to just crouch down and hide. So, yeah. Anyway.
You can see Whisper is consuming a rather sizable rat. Now, if you can see my fingers up here, just to give you perspective, right? Whisper's head was about that big. Okay, it was pretty small. However, the rat that she would consume would be about that big. Now that's quite a lot bigger. Scale it up.
And this is not anything I did. He was talking about the scale and didn't have himself up on the camera so we could actually see what he was saying. So sorry about that. But yeah, I have no idea how big these rats are that he's talking about here because I couldn't see his hands. Secular rarity, it sounds like it might be interesting to smell in 3 stuff from months ago, but sometimes I have a bad enough time smelling stuff that's here now. I don't want to smell funk and grossness from months ago as well. That's one of the things I always thought was funny about like people like, oh, I want to be Wolverine. Wolverine's powers are great, except for that super sense of smell that he has, because, yeah, I don't want to smell someone's fart from 3 rooms away. I don't want to smell the garbage in the garage while I'm trying to sleep in my bedroom. No.
Even more to our larger snakes like our Burmese and our boa constrictors, and their heads were about that big, yet they were consuming large rats or even sometimes rabbits up to the size of sort of somewhere in between there. In other words, they're consuming something which is far, far larger than their mouth is in a normal closed position. It's something far larger than their head is in a normal closed position. And I loved asking people, okay, what is going on here? What can snakes do in order to actually fully ingest this creature, this food source? And the answer that you got every single time was, oh, they dislocate their jaws. Now, I don't know if that's something that you hear over in the USA and in Canada, or
we do, Joe, and yeah, I'm on board with you. It's a kind of a silly urban legend about why snakes can open their mouths so wide.
I've been to Australia, and they certainly believe that over there. I think I've done this presentation in the USA, and I'm sure that was used over there. It's something we come across all the time here in the UK, but there's the actual fact. Snakes do not dislocate their jaws in the slightest, simply because they do not have jaws for which they can dislocate. Let's have a look at the diagram here. This is an...
It would be more accurate to say that snakes have a hinged jaw with two separate mandibles. Mandibles, lower part of the jaw, that are separate. So they actually act like, and he's going to get into that in a minute, but I just wanted to clarify that their jaws are not dislocated. They're hinged, and each side of the mandible is independent of the other.
An actual adder skull. What you can see, 2 things immediately. First of all, they have a little bone called a quadruped bone, which sits on the back of their jaw. Now, this is a bone which can actually create an extra lever to fold out. They don't unhook their jaws, they don't dislocate their jaws, they simply can open their jaws very, very wide. The other thing which you can see, if you have a look at where the snake's chin would be, you'll see he doesn't have a chin. Now, if you get a snake and turn them upside down, you can see a little line there, and that line is actually a bit of skin which folds up into their mouth, so when they open their jaws really wide, it can actually fold back out and stretch open really wide. In other words, it's more of this kind of a motion rather than dislocating their jaws or an up and down motion like we have. It's a great design. It means that you can swallow great amounts of things.
And he's going to make a claim that snakes cannot chew here, which what we traditionally think of as chewing, maybe not. But you can see in this image that he has pulled up here, again, the mandibles are a bone, and then at the end there's spikes like a teeth. This is what this reminds me of is an ambly pigeon arm, cave spider. I've had I have one right back here. I don't know if you can. It reminds me of the way that their forearms are. That they're on this group. It's the Chelicera that it has that spike on it, or mantis arms even. But so they can't chew, but they at least what we consider chew. But those barbed bottom teeth on the mandible can independently push the food into the mouth down the throat. So that could be considered chewing, on at least analogous with chewing.
Now, snakes need this ability because they can't chew, even though they have teeth, and even though sometimes snakes have teeth that run all the way down their throat, they don't have the ability to chew. So they have to have it, which means they can actually swallow something whole. And they can do it pretty well. They can do it really well. They can do it really, really well. This is one of Australia's big rock pythons consuming a small wallaby. This is a fairly decent-sized meal. Of course, you do have to ask yourself, if you were going to shove that amount of food down your throat, would you be able to breathe? No, you wouldn't. Not even through your nostrils. Okay, and the snakes respiratory system just like ours, is wired up pretty much the same. The nostril and the mouth is all connected through the same pipe, so you've got yourself a little bit of a problem there. It can take over an hour sometimes. It can take half a day, depending on the size of the snake and the size of the meal, to actually consume this. How is he breathing? Well, again, clever little design. You can see
how he slips in design there. This is the esophagus for the snake is very unique because they need to keep their throat clear to swallow their food. It's that they had to evolve this. Do you think that's a good design to have your respiratory system connected to the same place as your digestive system, and to be able to be blocked by food? That so much to the point that you have to evolve a special esophagus extension tube inside your mouth in order to breathe while you're eating. We don't even breathe while we're eating. We stop breathing when we swallow. Clever design. What about the way that insects and arthropods in general breathe? Because their respiration is generally in their abdomen, and is through spiracles. Yeah, they can't get as big, but they also don't have to worry about not being able to breathe while they're eating. Is it a good design? No, I don't think so. What do you all think, chat?
He's got a little tube down there. You can see it a little bit clearer in this little corn snake, but the bigger snakes, they all have them. This little tube is a bypass system. It means that it can actually stick it out the side of its mouth while it's consuming its food, and the tube goes over the top of its head so it doesn't get crushed. It runs down the back of his spine and into his lungs. So when he is consuming his food and his entire passage is blocked, he's got a little bypass tube which he can stick out the side and carry on breathing. Now, you do realize that all of these have to be in place in order to actually get a working snake. And it does lead to the question, how did these incredibly complex organisms evolve perfectly at the correct time?
Well, they evolved in tandem. Like, it wasn't just one thing evolves and then another thing evolves. It's successful reproduction. So the snake that could breathe better while swallowing larger prey was a more successful organism than the one that couldn't breathe better. So as they passed on these genes to have the better breathing mechanism in their mouth there, that tube that we're talking about, as they evolved along the way, the more and more successful, the longer the tube is. This isn't a complex situation. And then, with the venom, it's the one that had the tube plus the most potent venom was successful in this group. It's really you're overcomplicating things here, I think. All right.
And the point is simple, right? If you have a snake but he doesn't have a good sense of smell, he'll never find his food. If he has a good sense of smell and he can find his food, but he doesn't have the ability to catch or consume his food because his jaws don't open wide, then he can find the food but he'll still die. If he can have the sense of smell to find the food and he can open his jaws, but he doesn't have this tube, then he can find the food, he can start to consume the food, and then he'll die. Right? All of these have to be in place. And I haven't even started talking about the fact that if you start...
This is like Ray Comfort level incredulity. How did the dog waiting for the other dog to evolve, and had to evolve eyes, and then had to evolve a mouth, and these things all, again, in tandem. It didn't happen independently or individually.
Stuff yourself with that amount of food, you'll explode, right? A snake has to have a body designed to be able to cope with large amounts of food. It all needs to be in place at the correct time, at the same time, and it all has to work together in harmony. Otherwise, you don't get a living snake for very long. The point is simple. If you want to get a working snake, it's got nothing to do with time, but everything to do with the process.
It does have to do with time, because populations, they reproduce and change and spread and decline all over vast periods of time, with different ecological pressures causing different changes in the germline of these organisms. And it takes time, definitely. So point one, I reward you no points for that. I'll tell you right now. Let's see what he says about processes.
get the process right, it happens very quickly, and you end up with a working snake. Get the wrong process.
There is different circumstances that can cause evolution to react faster. Dramatic environmental changes, extinction events, ecological shifts, biome changes. All these things can factor in to make an environment a niche vacuum for new organisms to fill a role in the environment and contribute to the whole ecosystem. So, as we all know, nature abhors a vacuum. So when these vacuums open up, evolution can take place, relatively quickly on a geological timescale. It's always happening slowly, but then we got to punctuate. It's called punctuated equilibrium, where there's these points where there's dramatic change, which causes these niche vacuums to open up, and just boom, everything changes. Just in a short period of time by comparison to how much it changes in a normal under normal, stable environmental conditions.
Process, throw lots of time at it, you'll never get all the components to come together, no matter how many millions of years you actually throw at it. And we dealt with this question earlier. How would you recognize a design if you actually saw one? Remember our definition of a design, and we'll come more onto it later. A design, if something has properties that do not come from the materials that it is made of, then it has been designed. And we'll deal more with this.
And that's saying that if anything that's more than the sum of its parts is designed, and that's not true. Everything. Like look at sodium, for instance. You mix that with chloride, so two independent, anyway, elements that have completely different properties, when combined, can create elements that have properties completely different from the two parts. So yeah, you're more than the sum of your parts. And I'm not going to get into the periodic table here. I could go on a rant, but let me get back to the video, because we're already pushing 2 hours here in just a couple minutes, and we're about to wrap up here. There's only a couple more minutes I wanted to talk about this
and explore a little bit as we go forward. Let's get on to the venomy stuff though. One deadly bite, because yes, it is true, in today's world, majority of snakes have a completely carnivorous diet. They're meat eaters. I say mostly because you can find many records of snakes eating plants.
Well, they're obligate carnivores. If they need certain nutrients in their germline, they can add that to their system. But you actually sent me down quite a rabbit hole here on this topic. I'm not gonna lie, it got really weird. As a matter of fact, let me show you where I've dived into here. Hold on, I think he's got about 10 more seconds.
Including things like grapes, and using their same specially designed jaws to actually consume large pieces of fruit. The document's there online, you can look it up.
Yeah, we're gonna talk about that real quick, because this is one of the biology stack exchange, is one of the places that I enjoy visiting. All right, bye, Junie. I think that Ian Davenport left too. I didn't get to say bye to him, but I was kind of diving into this topic here. So these pictures, it's been a little while ago that I saw these come through the thread. I haven't visited these stacks in a while though. Anyway, this is a snake eating grapes. It's a whip snake eating grapes. Snakes are obligate carnivores. That means that they cannot survive without eating meat. That's just the way that their biology is. Now, different organisms may need specific nutrients that they're not getting from their regular diet, that causes them to consume unusual things. You can see this in people too, but you also see this in animals. Animals like you could find videos of cows and deer and sheep eating birds, eating nestlings and chicks and ducklings and things. because they will. If there's nutrients there that they don't get in their regular diet that could be beneficial to them. They have a drive to eat it. Humans do too. We eat all kinds of strange things. I know when and there's things that you don't even think about, like chewing ice means that you don't know it. Your brain's not telling you, oh, you're low on iron, but that is why you have that desire to chew on the ice, is because your iron levels are low. If Dr. Ben's still out there in the live chat, I believe that's correct. I hope that's not an urban legend that I was quoting there. Oh, absolutely, Kyle. Yeah, we're about wrapping up here. It's been 2 hours. Let's get back to see what Indiana Joe has to say, because we're just now getting into the Venom. But yeah.
But in today's world, some snakes can be quite scary. I don't think they're all scary, but I certainly wouldn't want to come across this fellow when he'd got out of the wrong side of the bed in the morning. This, of course, is a western diamondback rattlesnake. You've got them over in the USA. Some of these snakes, Australia has more venomous snakes than non-venomous snakes. That's a pretty serious quantity of rather deadly creatures, right? There he is with his shaky tail warning you to stay away. And of course, if you don't stay away, he can inject you with his deadly venom.
Yeah. This is just giving you some basic biology. I don't think there's anything wrong with this. This image of the venom dripping from the fangs is sort of the common thing to see when you're talking about rattlesnakes, and this pushes this narrative that they're this deadly monster that needs to be destroyed. And they have these rattlesnake roundups in the Southwest that are pretty gross, because rattlesnakes are, yes, they're venomous, but they're also long-lived and fairly social animals. It's really sad to see them being treated like just desert monsters. They're not. They're animals. They can live for like 50 years. So they catch and kill these rattlesnakes and their babies. It's sad. That's an animal that could have went on to live decades if they hadn't caught it and killed it. Anyway, sorry, I get a little hot under the collar about that.
Toxins, an extremely complex mixture of toxins and enzymes which can cause great amounts of damage to you. It's a pretty dangerous creature. Why would a good god make something like this? Well, to really get to the bottom of the issue, you need to ask yourself some questions. You need to ask some questions like, why would God create Venom in the first place?
You guys ready for the questions?
Could Venom be the result of the fall? The fall of mankind, we're talking about a creation that is made very good. Man messes up. The woman was deceived. Man willingly chose to eat of the tree of the knowledge of good and evil, and as a result, the earth was cursed. Could Venom, which in today's world is pretty bad, be a result of the fall of mankind? Could Venom have had a different use in the beginning? That's an important question. Could Venom have got worse after the curse? So maybe it didn't do damage before, now it does. And of course, another important question is, are there any vegetarian animals that are also venomous? Because if there were, it would give you a clue as to what Venom's true use is.
Well, I don't want to miss the questions. Hold on, let me pull it back up here. All right, let's look at these questions. Okay, why would God create Venom? Good question. A god that was wanting a balanced ecosystem, I guess, could use venom as a way for meso predators and smaller prey animals to defend themselves or to catch their prey from animals in a higher weight class. You notice that most venomous animals are relatively small, or on the small side. So, yeah. Is venom the result of the fall? No, venom is the result of several different lineages of evolution converging on the same physiological traits in order to subdue prey or protect themselves from predators. Could it have had a different use? So venom, can be used as for food and for catching prey and for defending yourself from predators. Again, venom is a multi-tool. And the notion that you have venom can be enough to deter a lot of predators and a lot of negative interactions. Could it have gotten worse after the curse? I don't believe in curses, so I really can't answer that question honestly. Are there vegetarian animals that are also venomous? Yes, and the main one that comes to mind are slugs and snails, especially sea slugs. Are There's species that are vegetarian and pterosaurs, and yeah, they're venomous. All right, so we answered those questions. That was pretty easy, actually.
Because if there were, it would give you a clue as to what Venom's true use is. Okay, now there's been lots of different creationist ideas about Venom over the years. Several mainstream creationist organizations, you can go onto their websites and Google stuff, right? And you can find a whole host of ideas. Most of them, and I don't say this lightly, most of them are wrong. And I'll explain why. Here's some ideas, and you can find these all over the internet, right, on creationist sites. God equipped snakes with venom in order to survive in a fallen world. The premise of this is that venom is obviously, it's a bad thing, and so
But why is it bad? I don't get that. It's good. It's good for the animal using it. It's a very good thing. Little tiny snake or lizard that's venomous has a lot better chance than a little tiny snake or lizard that's not venomous of surviving and propagating. It's good for the snake.
Equipped snakes with venom so that in order, foreknowing in his great and infinite knowledge, knowing that the earth would fall, knowing that there would be hard times, knowing that it would be hard to survive and there'd be deserts and things like that, he equipped them with venom in order to be able to survive in a fallen world. Other ideas is that venom was created after the fall. It was a result of the fall, just like thorns and thistles came onto the planet, and we're going to talk about that in a moment as well. The idea is that venom was created after the fall as part of this curse. Another idea is that venom just arose naturally after the fall. Now, okay, again, I really don't see this because venom is an incredibly complex mixture of enzymes and proteins and toxins all together. It does a spectacular job at what it does, right? It's not really something that could just come together by itself. Of course, the other idea is that God actually designed snakes to kill, but he physically limited them before the world was cursed. He stopped them from biting humans and animals before the world was cursed, even though they were in their purest form designed to kill. Now,
well, I don't know if they're physically limited. So it depends on the environment. Snakes do very well in an aquatic environment, in a subterranean environment. They're probably the most successful clade of diapsids in a subterranean environment. I would say that they, as far as I'm aware, correct me if I'm wrong, if anybody knows of any more successful clade than earth snakes. So they're really successful underground. They're also quite successful in the treetops. Snakes navigate through the treetops better than... I can't think of any other organism that doesn't fly that can navigate through treetops better than a snake, because they're not really hindered by anything. Any place their head can fit through, the rest of them can fit through or push through. So yeah, I don't think they're impaired in the way that you think they are.
Now, the problem with every single one of these ideas is simply this. It comes from a secular perspective. Here's the problem. Sir David Attenborough, Life in Cold Blood, great program, stunning visuals. I mean, spectacular photography, right? But here's what he had to say about snakes. Snakes are the ultimate killing machines.
I don't know if I would say that David Attenborough wrote that. He may have. I know a lot of these things are written for him to just read because he's got a fantastic voice, and I love David Attenborough, and he's smart about these animals. But they call it, this is hyperbolic, of course, because you could call, I've heard sharks called the ultimate killing machines. I call centipedes the ultimate killing machines. But yeah, it's just hyperbolic because they're really good at catching and subduing their prey. Ultimate killing machines.
You see, the problem with all of these creationist ideas about venom is they all hinge on the idea that venom is designed to kill. They all hinge on the idea that snakes are designed to kill. They all hinge on the idea that snakes are the ultimate killing machines. But remember the Bible verse we started with, let this mind be in you that is also in Christ.
Well, that's kind of a straw man, though, to say that this hyperbolic description of an ultimate killing machine means that they were designed to kill. just machine. The word machine here is being used hyperbolically. I don't think that David Attenborough actually believes that they were designed to kill.
Make sure that you get a biblical perspective. So let's dive in and see what Scripture actually says. I mean, this is evolution. This is what Richard Dawkins, David Attenborough, the BBC all promote and believe in. In the beginning, there was nothing. Some claim that there was something, or infinite universes, or you can go into the whole form of cosmology. But regardless of what sort of start you believe, a hydrogen all by itself, given enough time, turns into presidents and prime ministers. That's the premise of evolution.
Presidents and prime ministers. Protists to presidents and prime ministers. Molecules to man. Fish to fishermen. All these little euphemisms they use to snark at evolutionary biology. So funny.
Molecules all by themselves come together to form microbes, which go on to form monsters like the dinosaurs and ape-like creatures.
Molecules come together now to form organisms. How do you think reproduction works? It's not. This isn't novel information. We know that molecules come together to create organisms.
Creatures which go on to form mankind and beyond. A continuation of evolution. That's the basis, that's the philosophy, that's the background, that's the worldview that produces the thought that snakes are the ultimate killing machines.
Again, they're not literally saying they're machines that were designed to kill. It's hyperbole, my friend, hyperbole.
Solution, you need to get a biblical perspective. Genesis chapter 1 verse 31, and God saw everything that he had made, and indeed it was very good. In the beginning, God created. God created everything to perfection. There was no sin, there was no death, there was no disease. And then...
check this theropod serpent in the garden out here. Was it the serpent in the garden? Was it Silophysis?
This happened. The fall of mankind. Eve was deceived. Adam willfully chose to eat of the knowledge of the tree.
For real, Ring, Mega Man, ultimate killing machine right there. He has lasers for hands, or what are they, blasters, cannons, whatever you want to call them.
Of the knowledge of good and evil. As a result, as Scripture tells us, by one man, Adam, sin entered the world, and then death through sin. The world was no longer a good place. The world had changed from good to bad, and death had entered the world as well. And also things like these. Oh, this is from Jurassic Ark. John's spoken about Jurassic Ark many times before. Wonderful bromeliad plants. And can you see the spiky thorns on the side? And all of the prickly bits.
Yeah, bromeliads. I was just talking about this in the Facebook group, the Brainbug Facebook group. Again, I'm going to plug that here. If you're not a member and you're on Facebook, go ahead and join it. Just send a request to join Brainbug's Hive, and you can keep kind of ahead of the curve, because we a lot of the people in there suggest ideas for the show for me, and also post some stuff that I'm working on. So bromeliads are really cool. Because I was talking about pineapples. Pineapples are a bromeliad. Surprise! Yeah, they are a bromeliad, and they actually they digest you if you eat pineapples. They are digesting the surface area of your mucous membrane. So they have digestive enzymes as well. It's Titan in the chat. I don't think Titan's in the chat today, but Titan, Uranus, and I have talked a bit about bromeliads. There's some bromeliads that are predatory, that have pit traps that insects fall into. So bromeliads are an interesting clade.
Yeah. I mean, we have loads of these examples at Jurassic Ark, and we're trying to develop a botanical garden over here in the UK as well, although it's a little bit harder than in Northern Australia, where it's nice and tropical, right? Spiky things on the sides. Nasty things.
Spiky things that's a technical term. Thorns and barbs is what he's talking about here.
Hey, you wouldn't want to, accidentally sit down on that, would you?
Nope.
Spiky, nasty, horrible.
It evolved to make it so you didn't want to sit down on it too, because it's trying to protect its foliage and its fruit from predation, or not predation, I guess, folivory, and frugivores. Yeah, folivores and frugivores. Thorns are evolved to protect the plants from.
Not good at all. Things that will hurt you, things that are painful if you grab hold of them.
Again, having these spikes, these barbs, these thorns, these for poisonous plants, or like poison ivy, things like that, those are good for the plants. It's good for them. It helps them. It's not a bad thing. You're very human-centered.
Thorns and thistles. Oh, by the way, all thorns and thistles are the result, all spiky things on plants are the result of mutations. In this
all spiky things. I want citations, please.
case, well, you can see part of the mutation problem there. Part of this plant is not doing its job. Part of this plant is not actually producing chlorophyll, producing, sugars from the sun.
Right, D? We don't kink shame here, do we?
Because it doesn't have any chlorophyll, it's just white. But you notice the little spiky things? They're quite interesting, because what you have is a mutation that means that the plant has shrunk, in this case anyway. And as a result of that, the little tubes, which are made out of silica, which is glass, get left behind, because the plant has shrunk and the tubes get left behind, and the sharp little bits of glass stick out the side and form these thorns.
And most grass has an edge like this too, if you look at it under a microscope.
These are the true thorns in the technical form, and other thorns, which are the failed sort of stem or branches, as the branches begin to grow out and the shoots grow out and they fail and they end up being hard and spiky. Those are the true thorns. The prickles, like on the roses, are a mutation which has caused a sharp thing to stick out of the side of the plant, actually produce a mutated part of the plant. But they're all the result of degeneration. They're all the result of mutation. They're all the result of devolution.
All right, and that's about as far as I'm going to go on this. De-evolution. De-evolution. What do you all think of that term? De-evolution. It's really evolution in a direction that he doesn't expect, or doesn't accept as that it is evolution. So, yeah, I mean, what are you going to do with that? Anyway, so that was CreationWatch. We had our repeat visitor, Joe Hubbard. What's his ministry called? I can't remember. I'll try to remember next time I talk about him. Or if we actually are able to get him in a live interaction, that would be amazing.
Evolution.
Believe in evolution.
Yeah, tell them that you believe in evolution. Evolution.
Evolution.
Evolution. Yeah, tell them that you believe in evolution.
Evolution.
Yeah, tell them that you believe in evolution. You're not going to get us to not believe in evolution.